Okay. All right, so what I want to do, what I've done is I've gone through the test results from yesterday for this period, and I've looked, I just kind of did an analysis to see where we had the most trouble. It's pretty clear there were some areas where people were struggling more than others. So what I proposed today, I want to go through and revisit those. So and this is from the test. I'm literally just pulling up a test, like you did, and we'll just take a look at it. Really, there's probably 5 or 6 that were really pretty bad, and then there were some that were sort of bad, and we'll look at all those too. And the goal is, for you, then, is to come out of this knowing where you went wrong. In some cases, you're going to find, I think, that it might have just been you didn't really read the question carefully, or it might have been an issue where it's not that big a deal. It's not really an issue of understanding. But I think in a lot of cases there may have been something more than that. Okay, so, all right, so what about one like this? We're supposed to solve the inequality, and they want you to do 3 things. And one other thing, let me just also point out that this is why, I think, going into that test yesterday, why it's so important to finish up the review. The review is the most important assignment in the unit. It's the one that matches the test the most closely. And then, so that's really critical. You got to get that done prior to the test. The people that did, the correlation was phenomenal between, yes, sir.
Is it next year, guys?
I don't have any. I think there's some in one of the labs done. I think the 205 or something. Yeah. So, if I looked at thank you.
Ain't mine on the way up.
Excellent, thank you. If I look at the correlation between the people that did the review, even if they didn't even finish it, if they did most of it, and the scores it was huge. People that hadn't done much on the review didn't do well on the test, and that's probably not surprising. The other thing is I want to point out is that practice test over the weekend would have been a great idea. The people that did the practice test all got A's, I think. I'll have to double check that, but I'm pretty sure everybody that did the practice test, you got A's or B's. It made a huge difference to actually be able to go through and see kind of the test format and stuff beforehand. Okay, so back to business here. So they're wanting us to do 3 things. They want us to, they want us, without even thinking about the specifics of the problem, what's the answer going to look like? And then the second part is, okay, based on that look, what numbers would we have to plug in for A and B for our specific answer? Okay? Let me make that a little bigger. Okay, so the part that the math that's really critical here is knowing what kind of trade to make. Right? We know that if we have an absolute value inequality, we have to make the right trade or we're sunk from the beginning. So what do we do if I have an absolute value expression is greater than a number? What form does that send us to immediately? 4. Good. It'd be 4 or 5, and because this doesn't include an equal sign in the inequality, it's 4, right? Okay, so then we got to know what A and B are. So we know that it's form 4. And this is the part where I think in some cases people got the right answers, but they just weren't careful about putting them in the right places. Now this is kind of an issue though. A in this case refers to the left boundary. A is the number X is less than. B is the number X is greater than. So let's find those. So we're going to rewrite, first of all we have to rewrite this absolute value inequality. How? What does that become? The absolute value of 2x plus 1 is greater than 11. So what do we do with the argument of the absolute value? Okay, we know it's going to be an OR, right? Right? So how are we going to set that up?
Or.
Okay, we got to use OR. If you want to take a shot at it, right? Do you have an idea? Say it again. Okay, we're going to subtract 1, but before we can do that, and this is really critical, before we can do that, we have to do something else. Ezra, you have an idea? Take away the absolute values. Good. So we have to rewrite this before we can do any algebra. This and make sure that this is one that I can't state this loudly enough or with enough emphasis, you gotta get rid of those absolute value bars. You can't do algebra with the absolute value bars there. You gotta get rid of them. So we're gonna make the trade. We already know it's gonna be an or kind of expression. So we're gonna make the trade then for 2x plus 1, whoops. 2x plus 1 is greater than 11. That's part of it, right? Or 2x plus 1 is less than
Negative 11.
negative 11. Perfect. If you can do that, you're home free, really. From there on out, it's not that big a deal. Now the algebra is pretty simple. What are the two steps in order we got to do to get the x by itself? Subtract 1 and then divide by 2. So if we subtract 1 on this side, we get 2x is greater than 10, right? Everybody agree? Divide by 2. Do I need to flip the sign? Nope, I don't, because it wasn't negative, right? So I just get x is greater than 5. That's part of my answer. Or, what about over here? If I subtract 1, I just get negative 12. Agree? 2x less than negative 12. Divide by 2. And I get x is less than negative 6. So those are my two answers, but which one goes there? Goes where? Which one is A and which one is B? Good. Negative 6 is A, 5 is B. It's always just numerical order, isn't it? The left boundary has to be the smaller value of x, the lesser value of x. B has to be the greater value of x. So this is a negative 6. That's a positive 5. That's it. Okay. Questions on that? Does that make sense? Okay? All right. Moving on. Okay, the next one for you guys would have been well, while we're at it, let's just do 16. Because they're almost the same. Okay, what about this time? Okay, don't get sidetracked. Don't get sidetracked. Okay, what about on this one now? Well, this is different, right? You got to be careful when you look at this thing originally. You got to be real careful that you make the right trade. Still got to make a trade. You can't do any algebra until we get rid of the absolute value bars. What do you think? Say it again. Form number 2. Good. Okay, so we know that we're going to do an and this time. So we're starting with, once again, we're starting with the absolute value, this time of negative 2x plus 2 is less than 8. And so what do we do to the stuff inside the absolute value bars for an and? Say it again. Make a sandwich. Yeah, think of it that way. We're making a sandwich. So this goes in the middle, negative 2x plus 2. And that's going to be pinched between what two numbers on the left?
Yes.
Negative 8. Good. And above? Positive 8, right? Okay? Everybody okay with that? Because that's the most important step. If you can do that, it's not a big deal from there on out. Okay? Okay, so what are the steps I'm going to do? The two steps in order to get the x by itself. First, I do what? Okay.
Right?
Amber?
Right?
Subtract 2 first, correct? Then what?
And then you're going to divide by, no.
Divide, you're right, divide by,
negative 2. No.
yeah, divide by negative 2, right? Okay, we gotta be careful with that. We're dividing by negative, but we're not there yet. We'll get there. So first we subtract 2, then we divide by negative 2. That'll get the x by itself. So if I subtract 2 from everything, those cancel, right? I just get a negative 2x in the middle. What? 6 here and negative 10 here. Agreed? Okay, now what? Good. Divide by negative 2. And what's that mean? Flip the signs. Very good. Okay, so we divide by a negative. That's going to flip the signs around. And then in the middle, we just get an x. Over here, we get our negative 3, right? Over here, we get that's a negative 2, so positive 5. Okay, that's our answer, but it's backwards, right? We got the inequalities going the wrong way. We got the left boundary on the right and the right boundary on the left. So we got to take the whole thing and do the glass trick. Same thing, remember, if we'd rather think of it this way, the glass trick is the very same thing as reading it from right to left and writing it from left to right. Remember that? So we start with the -3, then we get a less than going in this direction, x less than 5. Okay? Right? So now what are those answers? Well, how does that match? That matches form 2. A is the left boundary, so it's -3. B is the right boundary, so it's +5. And that's it. Okay?
Easy enough.
Easy
And
enough.
then you have to do it.
Okay? Questions?
Nope.
Okay, we're good there. All right. Moving on. Okay, next one. Number 1. I was a little surprised this one ended up being a problem, but the good news is it's easy to fix. Okay. All right. Is that gonna work over there?
Yeah, we're doing good.
Okay. All right. So simplify this expression. Now, simplifying just means order of operations, right? Okay. I think I know where people. There are 2 places that people in general maybe had a little trouble on this, and they're not major issues. This is easy to fix. Okay. First of all, if I follow order of operations, right? PEMDAS, please excuse my dear Aunt Sally, you might know it that way. Got to write it that way because the M and the D go together, the A and the S go together. I go top down. So what do I do first? Are there parentheses there?
Yes.
Yeah, there are. There are because grouping symbols count as parentheses. Absolute value bars are grouping symbols, right? So they count like parentheses. So then what do I have to do first? I got to work inside the absolute value bars. So inside the absolute value bars, can I simplify?
No.
I can't?
Yes, you can. Yes, you can. Yes, you can.
Okay, what is -20 minus 4? -24. Good, so the first step, we check off the grouping symbols or the parentheses, and we can rewrite this as absolute value of -24 over 2 cubed. Well, let's go ahead and do the second step too while we're at it. Exponents. Yeah, what's 2 cubed? 8, not 6. Okay, that's the other mistake that people are making. It's it's an easy mistake to make. You're in a hurry on a test, but this is an exponent, not a product. So 2 cubed is 2 times 2 times 2 is 8. Okay, what is the absolute value of -24? 24. So 24 over 8 goes to 3. There you go. Okay, good? All right, next. We did that. Okay, these. I don't know what to say about these.
Me, you know.
I don't think one of those are. Mine was the identity. Yeah, you can.
Okay, let's maybe just do a real quick review of these. Of each of these. Let's write an example. Let's write out what they all mean. These are the flashcard ones, though. How many people? I just want to be honest. How many people have made flashcards for these yet? Get some flashcards. Flashcards are magic. They completely work.
I just need 11.
All right, let's go through these. Okay. Okay, real quick. Commutative property of addition. Now, what's to commute mean again in math? If you commute to work, remember what we said about that. If you commute to work from home, you're changing places, you're exchanging places. That's all it is. To commute means to exchange in math. Okay? So the commutative property of addition, that's just the one that's saying I can exchange the places of things that I'm adding, right? Does that make sense? So if I have, this is the one that just says, for example, we'll just write some numbers up. 1 plus 2 equals
2 plus 1.
2 plus 1. That's it, right? Okay, so that's what the commutative property says. So then let's jump down to the commutative property of multiplication. What must the commutative property of multiplication say? 2 times 3 equals
3 times
3 times 2. Exactly. Okay? Associative property. To associate means to group. You associate with people in your group, right? So the associative property of addition, this is the one that says if I'm adding up more than 2 things, and we'll just use 3, that's easy. If I'm adding up 3 things, so 1 plus 2 plus 3, I have to add and multiply things in pairs. I just have to. So 1 plus 2 plus 3 would equal what? What does the associative property tell us? One plus the quantity, 2 plus 3. I can group them in any order I want to. I have to add them in pairs, but the pairs that I choose to add doesn't matter. Right? I can pair any 2 that I want to together. So that's associative property of addition. Associative property of multiplication while we're at it. That's just saying 1 times 2 times 3 equals, the quantity 1 times 2 times 3 equals, what do you think?
1.
Yeah, the quantity 2 times 3. So I can group them any way I want to, right? All right, identity property. Here's the key word for identity property. Identity, right? Identity means value for math. So the identity property means what am I going to add or what am I going to multiply and not change the value of the number. So for addition, 5 plus what equals 5. Identity has to stay the same. What's my magic number? 0. Okay, so 5 plus 0 equals 5. That's the identity property of addition. Okay, for multiplication, 5 times what equals 5?
1.
1. That's it. The identity stayed the same. 5 started with 5, ended with 5. Multiplied by 1 to make that happen. So that's the identity property of multiplication. Okay? Inverse property of addition. Now these two go together. Okay, so we can skip, that was not one we did, so we can just skip that one. The inverse property of addition, what that's saying is 5 plus what equals the 0 identity number. The additive identity number, which is 0. The special identity number for addition, we always know is 0. What do I have to add to a number to get that? It's opposite, right? Good, so I'm going to add the opposite. If I start with 5, I add negative 5. If I start with negative 7, I add positive 7, right? Okay, the inverse property for multiplication says 5 times what equals the the identity number for multiplication, which is 1. What do I multiply a number by to get 1 for a result? Okay, good. The reciprocal, right? So if I started with a 5 over 1, I multiply by 1/5. Okay, so the identity, to get back the identity number, I multiply by reciprocal. The inverse for addition means opposite. The inverse for multiplication means reciprocal. Okay, and then probably the easiest ones, the easiest one, because we can skip that one too, is distributive property. That's just one that says, you guys all know how to distribute. 2 times 3 plus 4. What is the distributive property? Tell me about that. What do I do? 2 times 3 plus 2 times 4. Okay? those flashcards. File them away. All right, so what's next? Okay, yeah, this is surprising.
You can borrow
Oh, nice do.
Your birthday's in February, but can I make you birthday? Or should I?
Mhm.
All right, there we go. Okay, this one, easy to fix. This is no big deal. This is, I'm surprised this one came up. Okay, so we start with this little inequality. One variable is all we got, right? We gotta solve for that variable. So 2x minus 6 is greater than or equal to negative 8. What are the two steps in order to get x by itself? Add 6, then divide by 2. So if I add 6, 2x is greater than or equal to what? Negative 2. Good. Now what? Divide by 2, so do I flip? Nope. Negative 2 over positive 2? Negative 1. So that's what I've got to graph, right? So where is my endpoint going to be? Negative 1. Is it going to be a solid or an open? It's going to be solid. So right away, there are a ton of these that we could just disqualify. That one we could disqualify, that one, this one, right? Oh, and then these two, because we know it's got to be solid. So we got it narrowed down to 2 right away. That's it. Okay, if it's got to be greater than, so it's going to be the one that shades to the right. So this is it right here. Right? Okay. Okay.
I should. Yes. No, because in season 8, the writers should get one and I do. They're season 8.
All right. Okay. Here's some. Listen. This isn't. We got to fix this. When we're doing stuff like this, now I understand. I freely admit that there's going to be some time when I got to pull this stuff up between questions. But here's something we need to work on as a group a little bit. What's not going to work is if every time I turn my back to pull something up, if just because there's a little downtime, if we kind of allow ourselves to get distracted and get off track, then this takes way more time. I would like, for example, today, this is going pretty quickly. I'd like to be able to get you guys down to the lab, and that's always my goal, but that's how we got to think about this. Let's be efficient, let's get this done. This is kind of when I'm between individual problems. Your job is just to be patient. It's going to take me a second to get it set up, but you got to just be patient with me and don't start talking and don't, right? Okay, probably the easiest question on the test. People miss this because they just weren't sure what the directions were asking, but it's an important thing to know. When it says simplify, people were trying to, I'd say more than half the time on this problem, people were trying to solve this instead of simplify it. But you can't solve this, by the way. Okay, you can only solve an equation or an inequality if you know what's on both sides. We don't even know what's over here. maybe people made the assumption it's a 0. I mean, I could see where maybe you could make that assumption. If it were a 0, we could isolate P and solve for it. But that's not what they're asking us to do, right? They're asking us merely to rewrite this in a simpler form. So what's that mean? Yeah, just distribute the 3 and combine like terms. That's it, right? Much easier. This is easier than solving. Although that would be pretty easy to solve that too, I suppose. If I distribute the 3, I just get 3p plus 9, and what can I do?
Combine my terms.
Those guys become 15. 3p plus 15, and that's my answer. That's it. That's all they want. Simplify just means rewrite in simpler form. Okay? So that's an easy one to fix too. I look for these scores to go up quite a bit on the retake. Okay, I think we're getting into areas now where I bet we don't have to do a whole lot more. This is stuff that we've sort of in a way already covered. We'll look at a couple more and then I'll just quit. Okay, what about that? If I want to isolate x, I'm solving for x. If I can point to a single x, I can solve for it. I can isolate it. I can point to one right there. It's in red. What are the steps I would go through to isolate that x? Okay, I could distribute. I could distribute the 4 and get, what, 4x plus 8 is greater than or equal to negative 20. That works. Now what? Subtract 8. Right? Divide by 4, do I flip?
Yeah. Yes.
No. Dividing by positive. Okay, so Jacob, what's negative 28 divided by 4?
7.
Good. So there's my answer. Did anybody do this a different way? Because there's one
Yeah,
other.
I
Yes.
did it wrong.
Oh. Okay. Well, maybe we won't do that way up there. Now, for the first step, let me be a little more precise in my question. For the first step, do we have to distribute? You can. It's fine. That was an okay way to do it. But is there a way we could not distribute? What could we do to that 4? Divide it. Yeah. Divide it, exactly. And technically, I'm not going to say one's more right than the other. Technically, that's what the order of operations really tell us to do. If we reverse order of operations here, and we're isolating, we go bottom up, right? So that's telling us that outside of parentheses, right? We don't get to parentheses until the very end. Outside of parentheses, is there anything to add or subtract? No. Outside of parentheses, is there anything to multiply or divide? Yeah, there is, right? I could divide both sides through by 4 and cancel those 4s, right? What's that give us? If I do that, I end up with just x plus 2 is greater than or equal to negative 5. And then there's no exponents. Finally, I get to parentheses. I can undo the parentheses and just subtract 2 more. Make sense? Okay, now why am I making a big deal? Well, I'm not really. I don't care if you do it either way. But eventually, you're naturally going to shift and do it this way. Because eventually, this is going to be important to see it this way. You won't have to think about it. It'll just, when we get to that point, it'll make sense to do. Okay, but that's kind of the process. All right, one more. And I think we've sufficiently gone through this. Okay, so okay, what's happening? People are talking. Yes, they are. Okay, what about this? Yes, ma'am.
Can we go over the ones like no solution, one solution?
Oh, yeah, absolutely. You're right. Good question. Yes, we gotta do that one too. Very good. Almost forgot. Okay, so what about this guy here? Is this statement above true for all real numbers? If so, what's the property?
Yes.
Okay, what's the property?
Hold it down.
Okay, now is it gonna be, those are the two that always get confused. Is it associative or commutative?
Usually where you move, right?
Yeah, commutative means to change places.
And what if
Aren't we just flipping places?
Yes, we are.
That's to commute. So this is commutative. Okay, now the next question is, okay, does it commutative property of addition, right?
No.
Okay, so is it true? Yes, it is. Now I can make this one not true though, right? This is the other, there was one that went with this. There are a whole bunch of different possibilities you could get for this. But what if we had one that looked like this? What if we had one that looked like A minus B equals B minus A? No good, right? It's not addition. It doesn't work for subtraction, nor do these things work for division. The important point on this question, really, you gotta recognize the property, sure, but the important point that's being made in this question is just that only for addition and multiplication do these properties work, not for subtraction and division. So that would make this one pretty simple, okay? All right, last one. The question about, yes, the question, I don't know which one that is, I gotta find it. Oh, that one. Some people miss this one.
What?
Yeah, seriously, some people, now you might not have had this one, but let me just make this point real quick. What's this answer? That's 9. Okay, this is 9. What is this answer? Negative 9. You understand why? Order of operations is saying here that we have to do exponents before we multiply by the -1. So it's saying 3 squared times -1. This one is not. This one is saying the whole thing, the whole -3, everything in the parentheses times itself. Okay? So that's it's not a hard problem, but it's really important to know that, because that's an easy way to make mistakes in science classes and other math classes and all over the place. All right, so where is this other? It's not that one. This one. This is the one you're talking about. Yeah, what do we do with this? Okay, so it says match each equation with the number of solutions it has. So if I pull down this little menu, each of these has the choice infinitely many solutions, no solution, or one solution. You got to pick which one it is. Very simple. If when you solve this equation, you get a single answer, it's one solution. So for example, on the top one, to solve this, wouldn't I just distribute to 3? Right? Okay, if I distribute to 3, can everybody see that okay? Let me rewrite that. If I distribute to 3, I just get the equation on the left, -9x minus 3. On the right, I get -9x plus 15 minus 1. -9x, yeah. So what do I do to get the x's together? Add 9x to both sides. Everybody see that? Everybody, because I got to try to consolidate the x's into one place. Well, look what happens if I do that. If I add 9x, they cancel. And on the left side, I get a -3. On the right side, I get 15 minus 1 is 14. So I didn't get x equals a number. It's not one solution. It's either going to be no solutions or infinite solutions. Which one? None. The equation that we get, how often is it true? How often is -3 equal to 14? Never, so there are no solutions. We'll start with n. Okay? What about the next one? Now this one here, I can see right away, I'm going to get a solution, can't I? I don't even have to finish the problem. If I distribute the 9 for this guy right here, I'm going to get 9x plus 45 equals -6x plus 8. Totally different. Now, if I add 6x to both sides, do you agree I'm going to get some number of x's? I'm going to get 15x? equals what? Well, if I subtract 45 over here, I just get some number, right? So I'm left with an x on one side. I'm going to get left with some number on the other side. I don't even care what it is. I just know I'm going to get one solution there, right? Okay. One more example. What about this one right here? Let's look at this guy. So with this one, if I distribute the 3, I get 3x plus 12 equals 3x plus 12. If I subtract 3x from both sides, they cancel, and I just get 12 equals 12. How often is that true?
Always.
Always, infinitely, right? Infinite solutions. Okay? Make sense? Okay. All right. Okay, that's probably good for the review. But the one thing I want to just remind you of today, I'm going to add another assignment. And here's the thing to remember. Whoops, holy smokes.